Hi everyone, this is Safo and welcome back. In the previous episode, we built a simple dynamic model of an AUV and analyzed the forces acting on it. Throughout the rest of this series, we will be using MATLAB extensively for modeling, simulation, control design, and visualization. So, before moving to more advanced AUV dynamics, let's take a moment to review some essential MATLAB tools that will appear repeatedly in future episodes. Specifically, we will discuss scripts, functions, plotting, subplots, and a brief introduction to ODE 45. Then we will combine all of these concepts in a simple AUV simulation example. MATLAB is one of the most widely used tools in engineering. In underwater robotics, it is commonly used for mathematical modeling, simulation of vehicle dynamics, controller design, and visualization of results. Throughout this series, MATLAB will be our primary engineering tool. Okay, MATLAB programs are usually written using scripts and functions. A script executes commands sequentially from top to bottom. A function, on the other hand, is a reusable block of code that accepts inputs and returns output. As our AUV models become larger, functions become extremely important because they improve organization and readability. In today's example, we will use three very important MATLAB tools. Plots allows us to visualize data. Subplot allows multiple graphs in the same figure. And ODE 45 is one of MATLAB's most popular numerical solver for ordinary differential equations. Okay, here. As usual, we begin by clearing the command window, removing variables from memory, and closing existing figures. This ensures a clean workspace before running the simulation. Okay, here we define several physical parameters. The mass, m, the mass of the vehicle is 50 kilograms. Okay, the parameter b represents a damping coefficient. Physically, damping models the resistance the oppose motion. Okay, and finally, F represents a constant external force acting on a vehicle. And here, okay, we define the simulation time. We want to observe the vehicle behavior for 40 seconds. Okay. Every dynamic simulation records initial condition. We assumed the vehicle starts at position 0 with 0 initial velocity. These values are combined into a state vector. And okay, here, this is the most important line in today's script. The function ODE 45 numerically solves differential equation. we provide the system dynamics, simulation time, and initial conditions. MATLAB then computes the evolution of the system states over time. The solver returns all state variables inside the matrix X. The first column contains position. The second column contains velocity. We separate them to make plotting easier. Okay. Now, here we visualize the results. The first subplot here will display the vehicle position, and the second subplot display vehicle velocity. Using subplots allows us to compare both responses in the same figure. Okay. And finally here, we define a MATLAB function. This function contains the mathematical model of vehicle. The state variables are position and velocity. The derivative of position is velocity. The derivative of velocity comes from the force balance equation. The function returns these derivatives to ODE 45. Okay. And now let's run the simulation and analyze the result. Okay, here the velocity starts from 0 and gradually increases. As the damping becomes stronger, acceleration decreases. Eventually, the system reaches a steady state velocity where the applied force is balanced by damping. And here, since velocity becomes approximately constant, position grows almost linearly with time. This behavior is exactly what we would expect from a simple dynamic system. Today, we reviewed several MATLAB tools that will be used throughout this AUV series. We learned the difference between scripts and functions, introduced ODE 45, and visualized system behavior using plots and subplots. These concepts form the foundation for more advanced AUV simulation. In the next episode, we will continue building more realistic underwater vehicle model. And thanks for watching.